the Raingarden assessment video. Hi, my name is Alicia. I'm a project manager intern at World Relief Seattle and Sustainability Ambassadors. Today you should have an assessment form with you, and if not, and you're just here to learn about rain gardens, enjoy the video. In this Raingarden assessment video, we're going to be looking at site construction, design, maintenance, and soil, and see if these filter water well enough. It's perfect to do this assessment a day after it's rained. And a reminder, if you have the form in front of you, we will be using cover class, which is basically turning percentages into numbers based on the coverage of the area. Some of the things you should have is a clipboard and the instructions, a marker, some pens, or you might have some pencils, a measuring tape, a spray bottle for when we do the soil texture part, some flags in case you want to zone off the parts in the rain garden and identify the inflow and outflow, a soil probe to dig up the native soils, a yardstick, a shovel, a flashlight, and here we have a multi-tool, but it should be a screwdriver. For personal gear, you might need some gloves, a vest, and refreshments that will last you 3 hours. What's also helpful is to have weather appropriate gear, so like jackets and things like that. My name is Risa Suho. I'm one of the project manager interns for World Relief Seattle and Sustainability Ambassadors, and I'll be one of your instructors for this video. This is site overview. For the first part of this section, we'll be figuring out whether your site is a rain garden, a bioretention, or if you really don't know, then it's okay to circle unknown. If we look at the site behind me, so because the design is simple and the site is relatively small, I'll circle rain garden. But if it's a bioretention, you can tell because it'll often be bigger, more engineered, more complicated. Part 2 of section 2, site overview, is figuring out how old your site is. And if you're like me, I actually don't know how old this rain garden is. So if you don't know, then definitely check with your advisor. How old is this rain garden?
Hi, I'm Lucas McClish. I'm the Community Garden Coordinator at Hillside Paradise Parking Plots. And these gardens right here are about 1.5 years old. And I know this because I was around when they were planted and built.
This is great, because now I've met the advisor who has checked off the age of this rain garden. So he will be my verifiable source. So now we're going to focus on contributing area, which means where the water is coming from, and hydrology, which means the study with the flow of water. So our contributing area, or where the water is coming from, is a high-use parking lot behind me, where the water comes from the parking lot into this rain garden. So this cluster of rocks right here is an example of an inflow, or where the water would come into the rain garden if there was rain event. And then right behind me is an overflow. If the rain garden has too much water, this is where the water would flow out to. So this is an overflow right here, intentionally built with rocks. And the potential blockage that we have are these sticks and those leaves, both of which are organic matter. Potential blockage percentage here is 0.5%. So this right here is an inflow, and we have a couple of types of blockage over here. So we have leaves, which is organic matter, we have rocks, and we have siltation over here. So we would say that the blockage of these are all around 50% because the water can either go through the jagged rock or it could go on the side going into the rain garden in a different direction. In this section, we're going to be talking about erosion, which is when rain or water washes away the soil. Hopefully you don't have any erosion in your rain garden, because erosion is a sign that your rain garden may be failing. You might be asked to look at the amount of erosion, which could be none, minor, moderate, or extensive. This is an example of a potential spot where erosion can happen. This is section 4, zone 1 conditions, part of the assessment. And in this section, we'll be figuring out certain measurements about zone 1. But you're probably wondering, man, how do I distinguish zone 1 from the other zones? I didn't even know that there were other zones. Well, don't worry. I'll tell you right now. Zone 3 is the outermost layer of the rain garden. It is the circumference. You can tell by this rain garden where zone 3 is because it's outlined specifically by rocks. Zone 2, you can tell where it is because it will slowly dip down into zone 1. Zone 2 is shaped like this because when the rain comes in, zone 2 helps guide the rain down into zone 1. Zone 1 is the deepest and flattest part of the rain garden, and it's built like that so the water can specifically stay in zone 1. So I'm going to eyeball where I think zone 1 ends and begins, and I'm going to use this flag right here to mark zone 1A. This is where I think zone 1 starts. And then I'm going to use this tape measure right here, and I'm going to say exactly where zone 1A flag is, and I'm going to extend it until I reach the point where I think zone 1 ends. And at the very end of my tape measure, that's where I'll mark zone 1C, the end of zone 1. And then in the midpoint, I'm going to be marking zone 1B with another flag to represent the middle of zone 1. I measured out zone 1 by seeing where the flattest and the deepest part of the rain garden is, and I separated that zone 1 into 3 separate sections so I can get an accurate and representative measurements of soil samples and substrate observations. In part 2 of section 4, the assessment will ask you to look for siltation, liner, filter fabric, and standing water. First, we're going to be measuring standing water depth in zone 1. What is standing water depth? Standing water happens when rainwater ponds or builds up in a small puddle in zone 1. And how are we going to measure that? We measure that using either a ruler or measuring tape to measure out the length of how far the water rose from the soil surface. So the next part is siltation depth. And what is silt?
Siltation is when medium or fine grains of soil end up clogging or stopping rain from going into the rain garden.
So to figure out how deep silt goes in your rain garden, you'd actually have to dig a relatively small hole.
In our rain garden, our silt has a sandy texture. We check for siltation because when fine, slippery soils cover up the spongy, sandy rain garden soils, it can clog the rain garden. In our rain garden, we're not seeing silt in zone 1, and if you find a silty layer in zone 1 of the rain garden, try to measure or estimate how thick or deep the layer is.
The next thing we'll be looking for is liner and filter fabric. Liner and filter fabric can be found under the rain garden soil mixture, so you're going to have to dig a bit before you actually find it. In this rain garden, we don't have liner or filter fabric, but in the case that you do find liner or filter fabric, it could look like this. Liner and filter fabric both look like blankets, and they both have a very fabric texture. But the difference is, filter fabric is permeable. This right here is filter fabric, so that means that there's very small holes that allows water to be passed through and filter into the soil under the fabric. But liner is not permeable, so that means that water should not be able to pass through the fabric. In this next part, we'll be taking soil samples of zone 1, measuring rain garden soil, compacted soil surface, and native soil. So I'm going to be taking a soil sample in zone 1C. So what I'm going to do is I'm going to put my soil probe wherever I think I should get a soil sample, and I'm going to press down firmly. I'm going to try to twist just a little bit if I'm feeling any difficulty from the soil. So I'm going to keep pressing down until I've reached the top of the core sampler where I can't see any space for the soil. And now I'm going to twist and pull up gently so I can get as clean of a soil sample as possible. This is my core sample.
What you see here are rain garden soils, which are typically darker in color and usually contain bits of rough sand for drainage. If we were to reach native soils with our sample, we would see a change in color and or texture. For example, we could see a change from dark, sandy rain garden soil to light gray clay soil.
Native soil is the soil that's found under the rain garden soil. It's the soil that was here before there was a rain garden. To measure out the depth of the rain garden soil mixture, we'll actually go down and see where do the rain garden soil mixture stops and where does the compact soil start. And for that, we'll see at around the 3-inch mark that the compact soil starts and the rain garden soil stops.
So once you take your soil sample, you're going to take your soil probe and you're going to lay it down on a tarp. And this tarp should heavily contrast the area around you so you can differentiate what is soil and what is the rest of the environment. What I'm going to do so I can get an accurate length of the soil sample is I'm going to, as gently as possible, I'm going to gently use my finger to push the soil sample from the end up so I can push more of the soil out. And I'm also going to take a screwdriver, and as I'm turning it over, just kind of gently scoop it out. So what we're going to do now is check for compacted surface soils. And looking at my sample, we can see it's not really holding together. It's a little softer compared to this sample of compacted soil. It's definitely a lot more brittle, dry, and it breaks apart super easily. Compacted soil surface is Raingarden soil. However, the main difference is that it's much more packed in, which means the soil itself is not good at filtering water because the soil is just so close together. Water can't enter or filter as easily through the soil as with the ideal Raingarden soil. So overall, soil is a mixture between sand, silt, and clay. But we're testing out this texture of our particular soil sample to find out whether our soil sample is made up of a majority of sand, silt, and or clay. So for the final test, I'm gonna see if I can ribbon this soil sample. So what I'm gonna do is I'm gonna take my index finger and my thumb, and I'm gonna gently but firmly press my soil sample through it and see if it comes out in a cohesive thin ribbon shape, and that is called ribboning. As you can see, my soil sample falls apart super easily, so it's definitely not a clay, and again, it's very gritty and it's falling apart, so I would categorize this sample either as more silt and sand or just completely sandy.
Now we're going to focus on substrate and vegetation. Substrate is just the stuff in the rain garden, and vegetation is the plants in the rain garden. When we're doing our rain garden monitoring, we're going to be using cover class.
Cover class is how much of the total space is taken up by plants or other objects.
For example, this ground cover behind me in zone 3 is 45% compared to the rest of all of zone 3 in this rain garden, so it would be a C classification. First, we're going to look at mulch, which prevents erosion and maintains the moisture of the garden. So right here we have coarse mulch, and on your site you might have shredded or fine. Shredded is a little stringy, and fine is kind of a mixture between coarse and the stringy type of mulch. And for us, we'd say that we have about an inch of mulch in the third zone, about none in the second and first zones. This is an example of bare ground, and compared to the rest of the rain garden, it would be about 15% or a B classification. So there isn't any gravel in this rain garden or any of the gardens that we have, but if we did, this is what the gravel would look like. For zone 3, we do have these rocks, but for zone 2 and 1 of our garden, we have none. So we would record the percentage of the rocks on the zone 3, and for zone 2 and 1, we would say none. For vegetation, we're going to do the same thing as we did with substrates and the rocks and identify the types in zone 1, 2, and 3. But for this one, we're going to focus on the plants. So now we're going to look at vigor, and vigor is the health of the plants. For this sword fern right here, you can tell that it's moderate because it has these green parts which look like they're about to grow and survive during the winter. And right here, you do have the rotting, breaking off kind of red part of the sword fern, but since there is so much green around here, it looks like the sword fern is going to regrow. Target plants are usually plants that we don't want in the rain garden. So like this weed over here, which is pretty typical, and also probably this weed over here that looks like grass. Just a couple examples. This is something of a deciduous bush. And then here we have herbaceous, and these ferns really do exemplify that because they are kind of like shrubs. This is an example of what an evergreen could look like. It has a lot of green even during the winter, and if you put your fingers on the leaf, it would be hard to pull it off. So this is an example of ground cover. It's usually less than 12 inches in height, green, flexible, and it typically creates more of a mat which covers a lot of area. For public amenities, meaning things publicly available, we're going to note things like, is the site pretty, can the public see it, and is it well maintained? For our site, if you drive in, the public is able to see it, but through the streets, it isn't very easily accessible, but it is well maintained and it is pretty.
Congratulations, you made it to the end of the assessment. Once you finish the last bits of section 5, go ahead and write down and circle in the end time that you finished your assessment. So don't forget, you should definitely clean your tools and put them away or give them to your advisor or whatever your advisor wants you to do. And with your finished assessment form, you should also hand that off to your advisor or teacher or whoever is there to take the assessment form. Thank you so much for watching the Raingarden monitoring instructional video at Paradise Parking Plots.